Hello everyone and welcome back to Infometrics Labs. In today's project, we will build an end-to-end Netflix movie recommendation system using collaborative filtering and singular value decomposition model. We will work with the Netflix Prize Dataset, explore the data, train a recommendation model, evaluate its performance, and finally deploy it using Streamlit. By the end of this uh, presentation will demonstrate how modern recommendation systems generate personalized movie suggestions. Before we begin, let me briefly introduce myself. My name is Debodip Choudhury. I am a data scientist and AI professional with experience in data science, machine learning, and large-scale data processing. I hold an MSc in Financial Technology with Data Science from the University of Bristol and a BSc in Computer Science from the University of East Anglia. This project demonstrates one of the practical machine learning systems I have built for my uh, portfolio. Why do recommendation systems matter? Recommendation systems are everywhere. Netflix recommends movies, Spotify recommends music, Amazon recommends products, and YouTube recommends videos. The goal is to personalize the user experience by predicting what users are most likely to enjoy. Instead of manually selecting content, recommendation engines learn from historical interactions and rank items according to predicted user performance. The project has five main objectives. First, loading and understanding the Netflix price dataset. Second, performing exploratory data analysis to understand user behavior. Third, training an SVD, singular value decomposition collaborative filtering model. Fourth, evaluating the model using root mean square error and mean absolute error methodologies. Finally, deploying the trained model using Streamlit so users can generate recommendations interactively and access the web application. The project workflow. This slide summarizes the entire workflow. We begin with raw Netflix data, clean it, perform exploratory analysis, filter users and movies, construct the user movie matrix, train the SVD model, evaluate its performance, and then finally deploy everything in a Streamlit application. This represents a complete end-to-end machine learning pipeline. The Netflix Prize Dataset is one of the most famous datasets in recommendation systems research. In this project, we initially work with over 24 million ratings from more than 470,000 users. The ratings correspond to around 4,500 movies in the selected data file, while the movie metadata contains over 17,000 titles. Dataset schema. Each record contains a movie ID, customer ID, rating, and rating date. The movie titles are stored separately along with release years. Since some movie titles contain commas, special handling was required while loading the CSV file. Before training any machine learning model, it's essential to validate the data. We confirmed that the movie title file loaded correctly, identified only 7 missing release years, and verified that all rating records contain the expected fields. Next, we convert the data column into a proper datetime format. This allows future temporal analysis if required. We also observed that 4-star ratings were the most common, suggesting that users generally rate movies positively. Here we see the overall rating distribution. Ratings of 3 and 4 stars dominate the dataset, while 1-star ratings are relatively uncommon. This indicates that users typically give favorable ratings to the movies they watch. The average rating is approximately 3.6, while the median is exactly 4. The relatively high average confirms the trend we observed in the previous histogram, where we see users generally provide positive feedback. Popularity here refers to the number of ratings rather than the uh, rating quality. Here we see that popularity, especially the Pirates of the Caribbean popularity leads with this much ratings. So high interaction volume gives stronger confidence in the rating signal. Simple average rating can be misleading when a movie has few ratings. This motivates filtering by a minimum rating count. High score is not equal to a reliable score. We need both rating quality and rating volume. Netflix-like systems must control for popularity bias. Filtering removes unreliable low-volume titles. For example, Season 1 appears as a strong, high-rated title. The result is more useful for business decision making. Most movies have very few ratings. So we are comparing the average rating versus number of ratings. We see that most movies has very few ratings. High volume movies show more stable average ratings. This scarcity pattern is typical in almost all recommender systems. So here we try to see the user activity distribution. We see that the mean ratings per user is 51.1 and the median is 24 and maximum rating per user is 4,467. Half of the users rated 24 movies or fewer, which contributes to the sparse user movie metrics. Here, we try to filter the users and movies. For instance, we keep users with at least 50 ratings. We keep movies with at least 100 ratings. We filter the dataset uh, sample 500 and we filter the datasets to 18,000 sorry to this much ratings. We reduce it and then we sample 500,000 ratings from this filtered dataset for our model development. So the sample contains around 134,000 and 443 users and 4,170 movies. Then we can compute the user movie rating metrics. Here the rows represent users, columns represent movies, and cells contain ratings. Missing values just indicate unrated movies. So we have 134,443 rows representing users and 4,170 columns representing movies. Recommendation datasets are naturally sparse. So here we calculate the metric sparsity. We see that there is 99% of missing values and 0.09% observed ratings. Users interact with only a tiny fraction of available items, and almost all recommendation datasets are naturally very sparse. So we need to do collaborative filtering to learn patterns from this highly sparse structure. So we do collaborative filtering using single value decomposition. Here, the user movie interaction matrix is decomposed into lower dimensional latent factors. These factors capture hidden patterns such as taste, popularity, genre preference, and viewing style. Then We load the dataset into the surprise model using the scikit surprise Python library, and then we split it into train and test datasets, and then we train using the SVD model. Here we set the SVD parameters to 50 factors and 20 epochs, which are very good. Uh, then we generate the predictions on test set to further evaluate our model. Then after we do evaluate on the test set, it gives us the results, and we can see the RMSE is 0.9842 and the mean absolute error is 0.7856. It's a good, these results are good. So our model predicts ratings with less than one rating point of average absolute error, making it a solid baseline recommended, making it good enough for its use case. Then we test our model, making a single prediction. We enter a random user ID of this, the movie ID and imposter, and it predicts the rating. Our model gives the predicted rating. This prediction is the core primitive of the recommender. We can estimate unseen ratings, then rank items by predicted score. The model recommends titles with high predicted ratings. So here we also generate personalized movie recommendations for the particular users. Examples include, for instance, the Simpsons movie Lost. So these are the movie names, the personalized movie recommendations generated by our model. So here we visualize, we do additional visualizations where we visualize the average Netflix rating per time. The average rating increases over time the sample, which can reflect changes in catalog composition, user behavior, or rating patterns. Then we try to see the distribution of the movies. So popularity is, as you can see, highly skewed. Many movies receive very few ratings, but a small number of titles dominate user engagement. So it's basically a very highly skewed left distribution of movie popularity. So here we can calculate the top 10 most popular movies. Note that popularity is not personalization. Still, useful as a baseline recommendation can support cold start users. Then we have to save the model. We train the model, then save it with pickle model file in order to power our web application. Um, and then we set our library requirements and in runtime environment in order to deploy it into the Streamlit. As you can see, this is a screenshot of our Streamlit web application. The user selects a Netflix customer ID. The slider controls number of recommendations. Model returns ranked titles with predicted ratings. And this is the architecture, deployment architecture. We connect our repository to Streamlit Cloud. We push all our code to a GitHub repository, then connect it to Streamlit Cloud. Then Pickle model is also there, and then the Streamlit Cloud gives us the user interface to interact with the application. So the app provides a lightweight interface over so the app is just like acting like an a very lightweight interface over our trained recommender model. This makes the notebook output easy to demonstrate to viewers and stakeholders. So um, so before this, let's give a short demo of the Live web application. I hope you can see the screen. This is our web application of the Netflix web recommender system. As you can see, this is the Netflix recommendation system. It recommends top movies for a particular users. So here we can select a specific user ID using this button. Yeah, here we see select 183 and recommendations. For instance, we can select 9 recommendations, and then we can just select this button to recommend movies for that particular users. And as you can see, these are the movies the system, our model recommends. For instance, for this user, specific user 195, our system yeah predicts uh, yeah 9 movies as in the slide, as controlled by the slide. So if the user wants 20 movies, they can go 20, or if they want 5, they can, or if they want in between like 10 or 9, they can also do that. So it's up to the user to see how many movies they want to be recommended by the system uh, for that particular data set. And so these are the movie IDs we have, and this is the predicted rating. So the system predicts that the AI is going to give a rating of this or to this. For instance, this user is going to give a rating of around 4.6 to this Futurama movie, which was released in 1999, which is a good. So it's it's predicting in order of the ratings. So this is the best movie the user is going to like, and in that way it gives a prediction of the ratings. Now let's go back to our PowerPoint presentation. So, what are the improvements we could make? We could um, add more content-based movie metadata and descriptions, like if the movie is a thriller movie, mystery movie, like genre of the movie, some more information about a movie. Then we can also uh, get some movie search and similar title recommendations as well, and we can add more images and make the user interface more richer, much more interactive. Uh, we can containerize with Docker. We can deploy a real-time API. Then we can also train on other. We can add other dataset files with it as well. So This project, in this project, we demonstrate a complete end-to-end recommendation system pipeline from raw Netflix price data to a trained collaborative filtering model, and then deploy the final model by building a Streamlit web application, uh, and then we get our results based on this. Um, so basically, thank you for watching our video, and please do not forget to subscribe and like our videos. Uh, Thanks.